So the observation about the need for long-term data preservation is probably a very good place to wrap up the early years of HDF. By this time, we've developed what HDF-5 would be. We've become a format of choice for a very wide variety of users, and we've begun to think about how we're going to serve these various communities. So in the next segment, we'll talk about the middle years of the HDF project. I'd say the middle years covered probably the years 1998 to approximately 2006. Probably the best way to describe the middle years is to say that the early years were ones of developing the basic technologies and beginning to see wide adoption of HDF, whereas the middle years saw important changes in how we as a group needed to work with a growing and changing user base. Of course, one of the biggest things about the years from 1999 onward were support of the NASA Earth Observing System. The Terra satellite flew in 1999, Aqua a couple of years later, and Aura a couple of years later than that. And scientists began collecting and using this data in earnest, and our support for that operation as it went into maintenance mode was absolutely critical. In 2002, we, together with Lawrence Livermore National Labs, Sandia National Labs, and Los Alamos National Labs, were very excited to be awarded one of the 100 RD100 Awards given to the 100 most significant newly introduced research and development advances of the year. Not only was it a validation of our work, but it also gave us a chance to dress up more than probably at any other time in the 22-year history of the organization. The middle years saw a significant change in the user profile. We saw especially a number of new applications and visionaries finding that HDF satisfied some of the data challenges that they were facing. Boeing was an industrial partner of NCSA, and they adopted HDF for several projects involving flight testing, including the 787 project, and we worked with them closely on that. Vehicle testing at the Aberdeen Test Center in Aberdeen, Maryland presented some very interesting challenges. This was an example of a group that generally used databases to gather the data when they did their vehicle testing, but they found that databases couldn't scale to handle the variety of the different kinds of data that they had to deal with, as well as the volume of the data. And so they turned to HDF-5, and now what they do is they take all of the data from a given vehicle test from all of the instruments, and they package it all in a single HDF-5 file, and then they take the metadata and put it in a database, and they have a very nice sort of hybrid system that combines HDF-5 with a database. Last I heard, which was several years ago, they already had 800,000 files corresponding to 800,000 separate tests in which they used HDF-5. Bioinformatics was another new area for us to get involved in, particularly with respect to genomic data. This is a good example of old technologies not being able to scale. In the genomic world, most of the data files until very recently were primarily text files, and they were fine until the instrumentation got to the point where it could produce far more data than text files can handle effectively, and so people began to turn to options such as HDF-5. We started working with a small company in Seattle called Geospiza in around 2004. Geospiza makes LIMS, or Lab Information Management software, for a whole variety of different users, from pharmaceutical companies to academics and so forth. Since that time, we've continued to work with GeoSpiza, and new sequencing technologies that have come online just in the past few years have really exacerbated the problem, and we're seeing an increasing groundswell of interest in the use of HDF5. It's not a standard yet, but we're working towards providing a version of HDF5 or interfaces to HDF5 that will possibly support standardization of genomic data in HDF5. Another area related to that in which we've seen the use of HDF5 is in biomedical imaging. Electron tomography, for example, can produce very large images. The image in this picture is 1/4 of a terabyte, and there are electron microscopes and other instruments that can produce even larger images than that. In around the year 2000, we learned that HDF5 was used in the making of Lord of the Rings, in the simulation of smoke and fog scenes. A couple of years ago, we learned that Sony ImageWorks had been using HDF5 for about 8 years, pretty much in the development of all of their animated films. They have a software product called Field 3D that uses HDF5 for managing the enormous amounts of data involved in CGI. Just 2 years ago, I think it was, they released Field 3D to the open source community. So we're beginning to see not just new uses of HDF, but new types of users of HDF, and new expectations were being placed because of that on the HDF group. People were coming to us and asking for actual deliverables. Could we add a certain feature to HDF, or a certain tool, or a certain feature within a tool, or help them do a particular thing with HDF? We were also continuing to see the interest and concern about long-term preservation of data. Another thing that we were seeing was, rather than folks coming to us to talk about R&D projects, people actually were looking for these deliverables in a short amount of time. They had a project that they were trying to do, and they needed us to be able to respond to them quickly. So we were seeing more and more of what you might call business opportunities, and then we were really facing the issue of how does a group within an academic community respond to these kinds of business opportunities. I remember one person in the University of Illinois contracts office telling me, when we were putting together a contract that involves certain deliverables, he said, we deliver papers, not software. And it took us probably 6 months to negotiate a way to provide a deliverable that would satisfy the university's stance on that matter. Data preservation is really not an issue that a university needs to or should be worrying about, except in the area of the libraries. And another issue was how quickly we could turn things around. A university is, again, not designed as a place where you come and you order some capability or something, and then they do it for you right away. So with issues of intellectual property and other kinds of contracts issues, getting just those new kinds of ways of doing things through the grants process at a university was a non-trivial thing to do. And finally, when you're trying to run sort of a little business, you need to worry about sustainability, and you need to worry about your assets. and the best way to be able to build up some assets so that you can be sustainable and you can survive through the ups and downs of the so-called business cycle is to be able to make some sort of profit and to be able to put that away. And that is an absolute no-no in a university environment. So we find ourselves in a situation a little bit like the fiddler on the roof, trying to survive in a life of uncertainty and imbalance. Tevye asked the question, and how do we keep our balance? That I can say in one word: tradition. Well, the traditions of a university weren't a good match for where we needed to go. We tried to find solutions to this set of problems within the context of the university. We spent more than a year working with the Office of the Vice Chancellor for Research, NCSA, and others within the university to look for a way to create a group within the university that would be more than a research group and could provide these kinds of services to our growing customer base. Ultimately, we were not successful. So we formed a little working group within the HDF group to look into actually creating a company and spinning off from the university. We got this book, Business Plan Kit for Dummies, and we started working on a business plan. One of the first chapters in the book is about identifying missions and goals. We identified 5 missions. These missions would cover the different aspects of the organization we wanted to create. They were a public mission, software mission, service mission, human mission, and a financial and structural mission. I won't go into all of those missions, but the sort of general group mission for the HDF group that we came up with was the following: to ensure long-term accessibility of HDF data through sustainable development and support of HDF technologies. Having decided to take the plunge and spin off, there were still a number of questions that we had to answer. Did we want to be a for-profit company or a not-for-profit company? We ultimately decided to be not-for-profit because we wanted to be mission-driven and not change our mission after a couple of years. But if we're going to be not-for-profit, how are we going to make money? This is an issue that we're still struggling with, frankly. And then what about intellectual property? The university owned the intellectual property of HDF, but we had good support within the technology management office at the university, and ultimately they agreed to turn over ownership of the HDF software in exchange for a small royalty. So we began putting together articles of incorporation, talking to accountants, lawyers, and so forth, but there was still one problem. If we were going to spin off, how were we going to bankroll that process? Normally there are investors such as venture capitalists, angel investors, and so forth that will help you do that. But as a nonprofit, we didn't have people waiting in the wings to provide that kind of support for us. We really weren't able to solve the problem at first, and we kind of sat around for a few months trying to figure out what to do next. In December 2004, help arrived from an unexpected place. A company in the finance industry contacted some of our staff about coming to work for them. A division in the company had discovered HDF5 and they were beginning to incorporate its use in dealing with some of their data. We made them a counteroffer, and we asked if instead they'd be willing to contract with us, with our company, to address their needs. They were agreeable, to our surprise, and completely supportive of the open source nature of HDF5. The problem was we didn't actually exist as a company yet, and so we asked them if they'd be willing to help us financially to get started. And they agreed. They agreed to support us with a 2-year contract, and that gave us the guarantee of funding that we needed to actually get started, and in December 2004 we incorporated. Our plan was to complete the spin-off process in about 6 months, but it was much more complicated than we expected and took a lot longer, and ultimately we spun off after about 18 months in mid-July of 2006. So now we're a business. In the summer of 2005, we hired a business manager, but other than that, we were just basically a bunch of techies pretending to know how to run a business. Among the challenges that we faced, one was how to manage contracts. And as it turned out, because we had so many different types of customers, and because we weren't all that skilled in knowing what a contract should contain, we had a wide variety of different contracts, and that has been a challenge ever since. In fact, an auditor a couple of years ago told us that we had the most complicated collection of different contracts of any company that they had ever worked with of our size, or approximately of our size. Another challenge that we faced was keeping overhead under control. When we left the university, we figured our overhead rate would be pretty much the same as what the university's overhead rate, but we soon discovered that it was a lot higher than that. We didn't have a lot of the economies of scale that you have within a large institution like the university. So that's been a real challenge. Another thing is how we define profit. We wanted to be able to build up assets so that we could sustain the company over the long term, but we also needed assets to do things like maintenance of HDF in areas where we didn't have direct funding and that sort of thing. So that's been another challenge for us. One of the biggest challenges for us in the early years was accounting and budgeting expertise. We didn't really have an accountant on our staff, and we didn't, ignorance is bliss. We didn't really know what some of the things were that we needed to be doing. As it turned out, after a couple of years in 2008, we hired a new manager of finance and administration whose background was in accounting, and she basically transformed the company, not just in how we did our books, but in a number of ways that made it much more viable from a sort of financial perspective. And then the final challenge that we've faced is that of the business model itself. How do we make money? What do we do for the money that we make? And that continues to be a challenge that we're facing even today. We've done all right. If we look at the differences between the company in 2006, when we spun off, and today, we see definite growth. We have double the number of staff that we had then, similarly double the number of projects, and our budget is about twice what it was in 2006. The problem is about 60% of our income comes from just 2 projects, and that's too much reliance on too few income sources. It's not particularly sustainable over the long term. But that's where we are at the end of the middle years.